Hello there, my little lovelies, and welcome to another week learning with Miss Pitt. And today we are looking at chemical cells. So if you haven't done so already, please go and complete your retrieval quiz. All you need to do is highlight the answer on your student worksheet. So you've got multiple choice answers, you need to pick the correct one. Pause this, come back for your answers. Okay, so the answers are as follows. Make sure your green pen in. Just be careful because when temperature of the surroundings in an endothermic reaction, the temperature decreases because energy is taken in. In an exothermic reaction, energy is given out, so the temperature increases. Okay, so we are looking at chemical cells today. So remember, this topic is all about energy changes. So we're going to look at the energy change in a chemical cell. We use the word battery for the word cells in everyday life. So you need to describe what a chemical cell is. Some keywords. A cell is when you have two electrodes in an electrolyte which generates electricity. And you know those keywords from our lessons on electrolysis. A battery is two or more chemical cells connected together. An electrolyte is a liquid that has ions in it. The ions move to allow electricity to conduct through the liquid. An ion is a charged particle. An electrode, usually a metal, it's a conductor through which electricity enters or leaves an object. So you know in electrolysis we had our metal strips that we dipped in the liquid for our conductors, or we used graphite. So cells and batteries. Cells and batteries are used every day. We use them in many objects. So, for example, your phones will all contain a battery. Remote controllers contain batteries. A lot of your devices will contain some form of battery and cells. Now, the reason that batteries are so useful to us is because inside they contain chemicals, and those chemicals can react to produce electricity. So actually we're getting chemical energy stored inside the battery in the form of chemicals in reactants that can react together and produce energy. So we've got chemical energy stored in the battery, and when those chemicals react, they can then convert that chemical energy to electrical energy. Now, in physics, you should remember the symbol for a cell is this single one here. And if we are drawing a battery, we draw more than two of those cells together. So look at the diagrams, you can see a cell is one of those singular components on their own. A battery is two or more. So a cell is what we would call a single battery. So we would look at that in everyday life and we say, oh, look, here's a battery. Well, it's actually a cell. It's only a battery when you have more than two of them. So more than two cells joined together, it becomes a battery. So we've got a cell, we've got a battery. So task one, cell or battery? So pause the lesson video, go to your student assignment, decide if A to G, decide if they're a battery or if they are a cell. Pause the video, come back for your answers. Okay, so your answers should have been, we've got cell, battery, battery cell. So the potato was actually a cell. And that will become more apparent on the next slide as to what I'm on about. I'm not yet gone insane from working from home, even though I feel like it. F is a battery. G is a battery as well. Now, G does actually look like a cell on its own, but is actually two single cells inside of that metal block. Okay, so how chemical cells work? How do they work? So to build a chemical cell, you need three components. You need two metal electrodes, and they have to be different metals. And then you need an electrolyte solution. So I could get remember, an electrolyte solution is a solution that's got dissolved ions or melted molten ions that can move. Okay, so it's the ions in the electrolyte that allow the current to flow through it. So if we look at this diagram here, some of you might have made this actually at some point in science. So the juice inside of the lemon can actually act as an electrolyte because it's got ions inside of it that can move. Now, we therefore, in the picture, you can see we've got two different metal electrodes. We've got a copper nail and we've got a zinc nail. And you can see if we connect those in, by wires into a circuit, the LED light bulb lights up. Now, you know that we can also use a salt solution as an electrolyte because by dissolving the salt in water, the ions are free to move. We can put two strips of metal into the solution, connect them with wires, and if you connected a voltmeter, it would show you a voltage. It would show you a potential difference. So the potential difference is another word for voltage, and it's the difference between the metals. So remember, the metals need to be different, and one metal will be more reactive than the other. And it is that causes the flow of electrons. Now, the electrons will flow from the more reactive metal to the less reactive metal. So if we look at our reactivity series of metals, you should recognise that. That's nothing new. You can see if we looked at copper and zinc, copper is relatively low at the bottom, fourth one from the bottom, whereas zinc is just below carbon. So zinc is more reactive than copper. So the electrons flow from the zinc electrode over to the copper electrode, and that is what is causing the flow of electrons. It's the difference between the two metals. Now, a typical voltage of one cell is 1.5. So what voltage would I get if I had two cells together in a battery? Good, 3 volts. I've got two 1.5 cells and I'm adding them together to make a battery. I'd get 3 volts. So sometimes because the cell only produces 1.5 volts, the potential difference in a cell is only 1.5. To increase the voltage of that battery, of that cell, you can connect more cells together to form a battery, and that is why we have batteries as well. But if you look at this diagram, you can see we've got magnesium, we've got copper as our electrodes. Remember, we need an electrolyte solution with ions dissolved in it to move. Now, if you look at the reactivity series, you can see that the electrons flow from the magnesium to the copper because the magnesium, guys, is more reactive than the copper. So the potential difference, the voltage, is causing the flow of electrons to go from magnesium to copper. Now, the magnesium electrode is the negative one because that's where the electrons are flowing from. And the copper is the positive electrode because it's drawing the negative charge towards it. So task 2, pause the video, complete the checkpoint questions, come back for your answers. Okay, so your answers are as follows. So the three things needed to make a chemical cell: two different metals and an electrolyte. Name two metals, any two metals you could have named. A battery has a higher voltage. Danger, danger, high voltage. Number 4, ions move in electrolyte. Number 5, zinc is more reactive. Chemical energy is stored in a cell. The transfer of energy is chemical to electrical. And if the two electrodes in a cell were magnesium and copper, the electrons would flow from magnesium to copper. Okay, so you can get two different types of cells and batteries: rechargeable and non-rechargeable. Now, rechargeable means that you can reuse it. Non-rechargeable means that once the chemicals inside have reacted, it will run out. The battery will go flat. It will become dead. Now, the reason batteries do become flat is because as the current is drawn from the cell, so as the electrons flow, the chemicals in the cell are used up. So one of the reactants inside of the battery has become used up, so it can no longer react to produce electricity. So remember, guys, in a non-rechargeable battery, once those reactants have reacted and are used up, they no longer work. In rechargeable cells and rechargeable batteries, the chemical reactions can be reversed, usually by adding some form of electrical charge to it. So, for example, you can recharge your phone batteries by plugging it into a charger, which provides electrical energy to the device, which recharges the chemicals inside. So the advantages and disadvantages of using cells and batteries in everyday life. So advantages, the good things about it, is they're really convenient. Oh, I need a battery for my remote control so I don't have to move to turn my Xbox on or my telly on. Oh, let me just go and get some batteries. How convenient. How easy. They are portable. Portable meaning they're easy to move around. They're easy to transport. They're relatively cheap for what they do. And some are rechargeable, so they can be used over and over again. Now, the disadvantages of cells and batteries is what you'll notice is that some of them say, well, when the batteries go flat or dead and you want to throw them away, you have to dispose of them correctly. Usually, you take them to a disposal point in a supermarket, and they'll collect the batteries and send them off because they contain toxic or harmful chemicals that, if they get released from inside of the cell or battery, can damage the environment. So task 3 are your checkpoint questions again, just to check your understanding of rechargeable and non-rechargeable batteries. Pause the video, go and complete it, come back once you're done. Okay, so what type of batteries run out? Non-rechargeable batteries, sometimes you might hear them called alkaline or lithium batteries. Rechargeable batteries can be reused. Cells run out of charge because one of the reactants or the reactants are used up. Give two advantages of using batteries: well, they're cheap, they're portable, they're convenient, and some are rechargeable. And the disadvantage is that they contain harmful chemicals inside that can damage the environment. The consolidation, that brings us on to our consolibobs for the lesson. So what is the key word? So you've got 5 statements describing a keyword. From this lesson, you need to guess what that keyword is. Now, if you're stuck, 5 keywords are there, but they're scrambled up. So pause the video, go and complete this on your student worksheet, come back once you are done. Okay, so the answers are as follows. This type of battery can be reused, rechargeable. In a chemical cell, there are two of these, usually made from two different metals. Electrodes, of course. This is a solution that contains ions, an electrolyte. The bigger the difference between the reactivity of the metal electrodes, the bigger this will be. Voltage. Two or more cells together, it makes a battery. Okay, so one final thing for you to do is to rag rate the learning intention for this lesson. To describe what a chemical cell is, you need to go to your student worksheet, rag rate, add in your rag rating onto the dotted line. Thank you for taking the time to complete the learning year 10. Good luck with submitting your work. Hopefully, I will see it soon. I'll mark it, give you feedback, and then I look forward to next week's learning.